Hello, so I'm Tom Bide from the British Geological Survey. I work in the minerals team here, and I've been working on a project looking at sand mining for the International Geoscience Research and Development Programme. And for that, we've been doing a lot of work in Africa and Southeast Asia, looking at the impacts of sand extraction. So sand is a really important part of our everyday lives. It's mainly because it's consumed in concrete, it's easy to make, it's very strong, it's used all around the world in buildings and infrastructure, and really underpins sort of buildings and infrastructure for our modern lives. But the problem is it consumes vast amounts of sand, and in some areas in the world which are rapidly developing due to urbanisation and population growth, there is a huge increase in demand. And that's causing one of the largest flows of materials moved by humans we've ever seen. Causes huge amounts of problems with local environments where it's extracted from, and these can be very delicate ecosystems like rivers and beaches. So we at BGS have been looking at how we can reduce these impacts and reduce the consumption of sand. One of the things that we've been looking at is understanding how much material is actually used. Because one thing we don't know is actually where this material comes from and the quantities and volumes that are involved. Because sand is often an informal market, it's not well regulated, and it can often be illegally extracted. So we've been looking at ways to use remote sensing to understand where it's coming from and the volumes of material that's being consumed. And we've been using a range of satellite data and other innovative methods to understand the flows and quantities of these materials, trying to understand the cumulative impacts on the delicate ecosystems that it's extracted from. So when we do that, when we have more data and better data of kind of where this material comes from and where it's going, we can then start to think about how to mitigate the impacts. And this can be done from a range of different ways. And at BGS, we're trying to think about how geoscience can solve some of these problems, because obviously I'm a geologist, so I like looking at rocks, so this is something that interests me greatly. So principally, we need to think about moving away from extracting from the delicate environments like beaches and rivers, and moving to extracting material from where we can have better environmental controls, from quarries and areas away from active watercourses. We also need to think about reducing our demand, and of course that's really important whenever we start to think about reducing environmental footprint and decarbonisation, is using less. We can build our buildings better, using less materials. We can think about recycling old materials. And finally, we can start thinking about reusing building products as well, and also using alternative building products. In some cases, materials like timber, glass and steel can also form important substitutes for sand. So after a visit we've recently had to Malaysia, looking at how they've been dealing with sand extraction there, we've produced some illustrative good guidance practice that hopefully can be used by interested people all around the world who are affected by these issues. We've just published that on our website, so if this is something you're interested in, I'd recommend taking a look at that. And we've designed this to be really accessible, to kind of highlight the issues and highlight the ways that we can solve some of these really big problems. Moving forward, we hope to then sort of continue this work at BGS. We're looking at new and better ways we can use satellite data to monitor flows, and thinking about how we can implement some of these best practice examples. And we're looking now in case studies as well as in Africa to understand how different environments affects these materials in different ways, and how we can look at alternative products as well, looking at sourcing away from sort of beaches and rivers and these environments that we really rely on and really value as well.